Hi, in this video, we're going to introduce BGP, Border Gateway Protocol. So in other videos and maybe perhaps other classes where you've talked about routing protocols, we've talked mostly about interior gateway protocols. These are protocols like OSPF and EIGRP and ISIS and even RIP. And IGPs are used to exchange routing information within a single, we call them autonomous systems, but where a single organization, a single administration, where you have complete control of all the networks and all the devices and all the routers that are sharing this routing information. You have control over all these devices. An exterior gateway protocol, and there's only one out there, and that's BGP. Actually, the predecessor to that was the one before. It was called the EGP, Exterior Gateway Protocol. But the classification EGP now is used, and there's only one protocol, and that's known as BGP, Border Gateway Protocol. Okay, so this is the protocol that is used to route between autonomous systems. So if we see here, we have different autonomous systems. So these can be ISPs. They might be content providers, maybe Netflix, however you spell Netflix. I'll just put, there we go. Might be a university like UCSC. Sorry about this, it's not looking real good here, or whatever, all right? But they use BGP. Now, as you can see, what's different here is that they're actually routing between them and somebody else, okay? So they don't have control over the other end, okay? So there's a little bit of trust and mistrust here that's involved in BGP. All right, so let's talk a little bit more about this. So there's two types of BGP. There's external BGP, and that's what I just got done talking about. That's where we're using BGP to route between you and another autonomous system. There's also what's known as IBGP, internal BGP, and this is used to route within the AS. I won't go into why you would do this and where you would do this. I talk about this in my CCNP routing class. We go into BGP in quite a bit of detail on how this all works. But just know there's kind of two flavors of BGP. The routers that exchange BGP routing information are known as BGP peers or BGP speakers. So when do you use BGP? Because not all organizations that connect to a ISP need to run BGP. BGP is commonly used and sometimes has to be used when you are connecting to multiple autonomous systems. This is known as multi-homed. Okay, so here we have ISP1 that is connected to both this company and this company. Okay, meaning that they're getting internet routing information from both, and they can send internet routes, internet traffic to both. Perhaps it depends on how you actually want to do all the configurations, what we call policy-based routing. But when you do have multiple connections to multiple ISPs, you typically are going to need to do BGP. Yep. But you need to be very careful because any misconfiguration of a BGP router could have negative effects actually throughout the internet. If you are someone that is new to this and you're wanting to peer, let's say we are this company right here, and we're wanting to peer with ISP1 and ISP3 here, they're going to say, you know, we don't really know you. And if we're gonna have this peering agreement, and they don't have to peer with you, but I won't go into how these agreements work. But they've said, okay, we'll peer with you. They're not gonna totally trust you. They may even want to have control of the configuration of the routers that they're connecting to you. They may say, look, we're going to put a router there at your end, and we're going to maintain that. Now, why is that? Well, we'll see in the configuration command here in a moment, but you as this company here are going to advertise certain networks that belong to you. Okay, so public IPv4 and IPv6 networks that are part of your domain. Basically, what you're doing is you're telling your peers about these networks. Why are you doing that? So they can tell everybody about it, and they tell everybody, and that's what BGP does. So a company or a content provider over here that needs to reach you says, oh, I know how to get to that network, and it will determine what its best path is to get there via BGP, and it will be able to get there. Now, why am I going over all this? Well, I talked about it can have, if you don't know what you're doing, it can have negative effects. What if this company makes a mistake and in its configuration of its networks, and this actually has happened, and it's not completely uncommon. There are issues that do arise like this. And what I'm talking about, let's say they make a configuration mistake and they advertise the same IPv4 and IPv6 addresses that are actually part of YouTube. I'll just put YT for YouTube. Basically, what they're telling their peers is, hey, you want to get to YouTube? You come through me. They basically gave the wrong IPv4 and IPv6 addresses in their configuration. Well, what can occur is that all or significant parts of the internet might be sending their traffic instead of, let's say this is YouTube here, instead of traffic going there, they'll be sent to you. And guess what? There's going to be a lot of unhappy people out there, including the content provider itself and your upstream providers who you're pairing with. So this is why you have to be extremely cautious, and this is why you have to know what you're doing, and this is why your the people, the ISPs, the content provider, whoever you're pairing with, they're going to have a certain level of mistrust when it comes to pairing with you. All right. So when not to use BGP? Okay. Well, if you have just a single connection to an ISP, you don't need to run BGP. They'll have just a static route to your network, basically whatever public address space you occupy, IPv4 and IPv6, they'll have one or more static routes pointing to you, and you'll just send, I'll send all my traffic that is not specifically within my routing domain. For anything else, I have a default route that gets propagated to all my routers, that they're going to send it to me, and I have a default static route that will then send it to my upstream ISP. And no matter what, you can't be implementing BGP with just a limited understanding, or they're going to take, hopefully, your upstream provider will take the steps to make sure that they have a certain amount of control of your device and your configuration. Okay. Although it is recommended only in unusual situations for the purpose of this course, so what we're going to see in the configuration and when you do the lab, it's going to be single homed. We're not going to be doing multi-homing, and so we will be having a single home connection, and we'll do BGP just so you can see what it looks like. Okay, so I'll show you more of that in a moment. So what are the ways that some of the options for getting routes? So this company here, Company A, they may receive just a default route from their providers, meaning, hey, I can get to all the internet. I won't be specific here. I just have a default route, and I have two ways of getting there. So basically what will happen is if you have, in this case here, two routers, whatever router is closest to whichever edge or gateway router will use that router to send internet-bound traffic out, and it will go out that router. which may be okay, but sometimes that doesn't necessarily mean it'll take the best path. So maybe we'll go out this path where the other path would have been better to get there. Okay, so that's one. You just receive a default route. It's like having a 2 equal cost paths to the internet. Okay. Another possibility is a default route and the ISP route. So basically you're getting a default route and the routes of that ISP and the routes of that ISP. So each ISP is sending you a default route and sending you their own routes. So you'll know, all these routers in here will know, say, oh, if I want to, even if I'm on this over here, I know the best path to get to a network over here would be actually, we'll say these are connected. This router, and then out this way, instead of going this way. Okay. All right, another possibility is to do all internet routes. And the last time I checked, these are over 700,000 summarized routes. So you want to be careful when you're getting this many routes into your router's routing tables. So that means this router and perhaps some of your other routers. I won't go into the design aspects of this, but we'll know the best path to all internet bound traffic. So whether or not this is the best path or this is the best path to anything out in the internet. Okay, this is a lot of routes. Yep. So anyway, we talk a lot more about this in my CCNP routing class. It's a lot of fun talking about BGP and how the internet really works. All right, configuration. So again, we're just going to do a single home system here just to make this simple. So the first thing we do is say router BGP, and we give our autonomous system number. And by the way, a router can only belong to one autonomous system, okay? Because it belongs, in this case here, it belongs to this AS number. And for the purposes of documentation, for the purposes of education, these the AS numbers, autonomous system numbers that we're using here are actually what we call private AS numbers. So these are not actual public AS numbers, similar to private IPv4 RFC 1918 address space. All right, then we use the neighbor command, and we just specify the IP address of our peer, of our neighbor. And we say remote AS number and give their AS number. Okay. And we're almost done. The last part of this is we need to say what network we are advertising. So this is the network that we are advertising to our ISP, telling them they can get to this network through us, and please inform the rest of the internet about this. Yeah. So this is the network address and the mask. Now, this does not need to be a directly connected network, as we have to do with OSPF, EIGRP, RIP, and different interior gateway routing protocols. The only thing is that this network address, in this case 192.168, 192, so used to saying 192.168, oops, 198.133.219.0, it must be in this router's routing table. It means it must be able to reach it somehow. Okay. And this is where I had mentioned you need to be careful, because if you make a mistake here, instead of 219, maybe you put 210, and that's somebody else's network. Guess what? Traffic for portions, and perhaps all, depending upon certain conditions that I won't go into here, but traffic for somebody else's network could be coming into your routing domain. Again, that's not going to make a lot of people very happy, and they won't be very amused. Okay. All right. So here's the configuration for the other end. So we can see that both ends Over here, ISP1 actually has their AS number. They have the neighbor here, the remote neighbor, and the remote AS here. And what they're advertising to you is a default. So they're just going to say, I'm just going to advertise a default route to you. So anything that you want to get to that's not specifically in your routing table, you can send that to me. Okay, so BGP is a fascinating, very interesting protocol, and I hope to see you in one of my CCNP route classes, or watch one of my upcoming videos where I'll be talking about BGP. So here on router A, we see that it has learned, BGP has learned about the default route. We had the administrative distance of 0. There's the next hop route. Show IP BGP. This is the BGP table. So all learned routes, both that are either advertised or learned via BGP, go in something called the BGP table. And one of the things that you will see about this, we'll take a look here, is notice here's the default route we received from our in this case, ISP1. Here's the next hop address. Something I want to show you here, here's the path. So 65001. So this shows you the path of autonomous systems that it takes to get to reach this network. What's very interesting is in the internet, if this router learned about other networks, that the internet looks at things as autonomous systems, not individual routers. So BGP, I should say, looks at things as autonomous systems. How many autonomous systems away? So we play around with this, looking at real IP BGP tables on real internet routers, and you can actually find like how many autonomous systems away are you from Netflix, from Google, from some university in Italy, or wherever it might be. Very cool. So hopefully maybe in another video I'll talk more about that kind of stuff, but very cool stuff. So the internet is looked at as the way BGP looks at routes, one of many ways. I won't go into all of it. One of the policies it uses to determine best path is how many ASs away, how many autonomous systems away it is. Okay, here's show IP BGP summary, which gives us some information about let's see, we got some good stuff here. This is this is company A here, our local AS number, our local IP address. Here's our neighbor's IP address. The V means we're running version 4. This is the remote AS number. Okay. And there's a lot of good information in this command that you'll learn about in CCNP route. So that's a little introduction to BGP. Border Gateway Protocol.